right, so I've been mentioning Docker quite a bit already, but let's take a step back and talk about what Docker actually is. Docker is an environment to develop, run, and deploy applications. It works by creating Docker images that contain programs and the dependencies. They turn into containers when they're run on the Docker engine, which is a container runtime. Containerd, a runtime, which the Docker engine is built on, might sound deceiving because your runtime makes you think of like duration, how long it takes for something to run. But really, it manages image transfer, storage, container execution, supervision. Basically, the list goes on. Everything needed to run in a container, aside from the program itself that's running on the container. It's also a daemon, so it runs in the background. And long story short, it manages the life cycle of a container. On to you, Sabine.
Thank you, Josiah. Now, there happen to be a few differences in terms of the way Docker runs on Windows machines versus Linux machines. On both Windows and Linux, Docker runs natively and has a lot of similar commands, but many of the main differences lie in the backend. For instance, on Windows, if you wanted to get Docker, you would download Docker Desktop, which is a graphical user interface based program with an installation wizard. On the Linux, on the other hand, you would download Docker directly from the website or through your package manager, and you'd only get Docker Engine and its management tools. The reason for this is that Windows tends to lend itself better to graphical user interface-based interactions, and so you would be able to interact with your containers or any resources you create visually. However, on Linux, people tend to make more use of the command line, so it makes more sense that the installation process would differ along those lines. In addition, on Windows machines, Docker uses a virtual machine using Windows Hyper-V, the Type 1 hypervisor that we mentioned earlier, and can be operated through the Windows PowerShell command line interface. On Linux, on the other hand, the containers handle all of the setup with no other virtual machine needed. The reason for this is that Docker is based on Linux containers. In fact, it was built for Linux, so it uses attributes from the Linux kernel to make and manage its containers. Because of this, Linux systems don't require any extra assistance from virtual machines to use Docker. If you're on a Linux machine, Docker already has the kernel at its disposal. If you want to create Linux containers on another type of kernel, like Windows NT, which is the kernel for Windows, Docker has to create a virtual machine with a Linux kernel to host those containers. That way, the containers will meet the requirement of having the same operating system as their host. Hyper-V happens to be the default hypervisor for Windows, so it makes the most sense for Docker to use. Plus, because it's a bare metal hypervisor, it has full access to the resources on the hardware and can allocate them to the containers as necessary.